Thank you for joining us today for our webinar on behavioral analysis and predictive analytics, the effective approach to ZOS performance management.
There's just too many inaccurate alerts. And inaccurate alerts cause lots of different problems. First of all, if there's too many alerts, people tend to ignore them. And of course, if alerts miss important issues, then again, people tend to mistrust them. And the reason this happens is that the alerting systems don't really have any explicit knowledge of what is normal. In order to be able to understand whether or not the system should issue an alert, the system needs to understand if the system is behaving abnormally. And in order to be able to do that, you need to be able to understand what is normal. And a lot of this talk will be around understanding and creating baselines around what is normal, and then understanding how to use those for alerts. And finally, by the time you see the alerts, by the time that the system issues an alert, what you're really seeing are symptoms. And that also leads me to the next issue, which is very important in IT today, and in many cases the users are the first to know. Because many systems, mainframe including, end users work directly with the systems through web interfaces, through mobile interfaces, and they are the first to know when something's broken. And that is not the optimal experience. What you'd really like to be able to do is understand that there's a problem before, and hopefully way before, your users actually know about it. So what happens if you're late? If you're late, what you get to see, and this is probably familiar to anyone using an alerting system, you see a cascade of alerts. You see things right up red all the time, a whole bunch of different things. And now what you're actually seeing is the symptoms. You're being alerted to the symptoms of the problem. And there's lots of symptoms to the problem, so you're being alerted over and over again to the symptoms of the problem. So if I could really turn back time and look and say, hey, what actually happened right before I was seeing all those errors? Well, then I would be able to understand that this is the issue, right? I have a certain task that's causing a problem. And then I could actually focus my efforts on that specific task to understand what was going on. So I don't really need to turn back time. What I really need is a tool that was capturing everything from when the anomaly happened all through the different stages and symptoms. So if I capture the anomaly early on, I've actually captured it very close to the root cause. So for example, what do you want to collect? That, of course, is one of the most important considerations when you're trying to figure out what you want to be able to predict and measure. What are the variables that actually affect the things that you're interested in? Now, the variables themselves may be a single variable that you get from your monitor, or it can be a combination of variables. But of course, monitors give you all the information that they can. They don't necessarily try to give you the information only that is relevant for modeling. So when you build your model, you want to be able to gather the relevant information from your monitors. One of the big issues around, especially mainframe and computer performance, is that there are lots and lots of parameters. So you need to be able to cut down the number of parameters being watched so that you can actually have a manageable set that can really be used and you can use to predict problems. And then you need to be able to find what an anomaly is. Not everything is an anomaly. And finally, if you could really understand this and you could create this prediction and understand how your system should be acting, then you can apply this knowledge to create dynamic thresholds. And if you have dynamic thresholds, there's a lot you can do with it. So dynamic threshold is finding an anomaly that says, look, I think the system is acting unusually at the moment. So how do you do a performance-informed prediction model? As I said earlier, the first thing you want to be able to do is to have domain awareness. You want to be able to have this domain awareness that knows things about performance monitoring, and you want it to be able to help you pick out what are the various kinds of parameters that you really want to look at. Then you want to take this and put this into a generic model. So I want to be able to build up a model, again, generic with domain expertise, to create what, as we look at this green highway there, what I think the normal bounds are for this variable or set of variables. So what's happening here, if I look at these red stars, I can see that here I'm in danger of going over my 4-hour rolling average. And these peaks, if something anomalous would happen in my system anywhere around these peaks, I would be pushed over during my 4-hour rolling average, and this could actually cause an additional charge. Well, first of all, you get improved performance because you can find anomalies before they degrade the service to users. Also, users are now calling about problems that are already known to IT. So instead of IT scrambling on every call trying to understand why is my system slow, how come no one knew it was slow, you actually know about the problems before they're affecting the end users. And of course, this causes lower cost. You can find anomalies faster, and this is an example of a system. It cost 10 anomalies before they degraded service or user. So in other words, they were finding issues before the service was degraded. As I said earlier, calls were coming in after IT actually knew about the problem rather than users being the first to know. And IT can now say, I'm working on it, and they understand where the problem was, and you can fix things faster. So that was a quick look, and only in the last chart I talked a little bit about ConicIT, but we're going to have another webinar where we're going to talk about the solution, the specific solution called ConicIT for behavior analysis and predictive analytics. We'll talk about how the product works, how it puts behavioral analysis to work, and how you get it connected into a system to start building into your behavioral profile and getting the appropriate alerts.
Thank you for your interest in the ConicIT Behavioral Analysis and Predictive Analytics webinar. There is a wealth of information on behavioral analysis and predictive analytics in this presentation. To view the entire webinar and to see Part 2, the ConicIT solution, go to our website stsusa.com and request the links for these webinars. Remember, you can request a free trial period for these and other STS products and partner products. Go to stsusa.com or call us at 1-800-443-6183 or write to us at info@stsusa.com. We look forward to working with you.